tools. So we've got Dr. Cara Stitzlein and Dr. Karel Mokany from CSIRO, who will be talking about the LOOC-C and LOOC-B tools. I know lots of you will be familiar with LOOC-C. It's a tool that can be used by farmers and others, such as us, to determine what carbon farming methods and activities might be possible or appropriate in different areas of land. And CSIRO have also recently launched LOOC-B, which is a similar online biodiversity mapping tool and can also be used to support carbon farming initiatives. Cara is working with CSIRO as a research scientist supporting projects within the land sector, such as digital agriculture and sustainability science, and she has an interest in developing digital tools and decision support tools that benefit Australian land managers while aligning to national strategies. While Karel has an ecology background and currently works with CSIRO and develops and applies modelling and assessment approaches to improve our understanding of biodiversity patterns and dynamics, helping to ensure well-informed biodiversity policy, planning and management decisions. Tools like LOOC-C and LOOC-B, they can play a really important role in helping us to understand carbon farming, and particularly of interest to this group, the co-benefits potential across Australia. So I'm really pleased to welcome Cara and Karel today, and I'll hand over to you.
Okay, Rachel, thanks very much. Is my audio coming through all right for everyone? Thank you. I've started using speech-to-text software, and so sometimes my voice goes a bit soft at times, but I think I'm going good today. Thanks for having me along today and for that really warm welcome, Rachel. I'll just open with my own welcome to country and just pay my respects to elders past, present, and emerging from where I'm joining the call from, which is the land of the Palawa people, otherwise known as Hobart. And I'll start to share my screen. Me should be getting there. Now, I do lose sight of the lovely faces on the call, so Rachel, I'm going to leave it to you to be sure to interrupt me as required if there are comments that come through or if something isn't presenting correctly.
Thanks, Cara. I was going to say, usually we sort of run to the end of a presentation, but I just thought for this one, and because I know Cara and Karel are going to run through the tools, that if you want to jump in, if you've got a question, and particularly when they're running the tools, if you just want to jump in and say, what does that mean, or how do I get to that bit, then please do just put up your virtual hand and I'll pick it up, or you can unmute and just sort of interrupt verbally if you need to.
Look, but that sounds great. And so what I thought I would try and do today is run through kind of our design intention behind these two tools and give a bit of information about both of them, probably emphasizing the recent additions we're making to the LOOC-C carbon tool and the LOOC-B tool biodiversity, as it's a fairly new offering that we have. And everything that you'll see on the slides I've already provided to Rachel as a PDF, so you'll have access to all the information and the links that are provided. Just to set the context from where we're coming from a digital tool standpoint, is that we think that they can be useful if and only if they meet certain requirements. And those requirements that we're trying to meet are those to support decisions, provide some level of assistance, and provide easy to use and accessible information. And so with that sort of scene setting, I'll be talking about the two tools. The look in both the LOOC-C and LOOC-B tool, it's meant to kind of describe just having a look into a possibility or an opportunity. And the acronym stands for Landscapes, Options, and Opportunities Calculator. C stands for carbon, B for biodiversity. And what both these tools are solutions that have aspects of both deep science and are built with human-centered design principles. Through our experiences releasing these tools, we see them as valuable conversation starters, conversations around carbon farming and the possible benefits that can come when you undertake those different land management practices. Both tools are available as free web-based tools, so you just have to go to a URL in your browser. Both tools are also available as an API or application programming interface. Happy to talk more about the difference between these two delivery mechanisms, but it should be sufficient for our purposes to kick off that an API is a sort of data engine. It runs queries that you see being run in the web-based interface. It's just more of a data science tool and one that can batch a number of queries to be run at the same time. Whereas the web-based tool is something you'd use as an individual looking at a specific property. What the tools aren't are crystal balls, nor are they a replacement for the decisions that you need to make about land management or market participation. It's really our aim just to provide the best possible advice and reduce some of the complexity around these land management change and the schemes. Someone mentioned when we opened up confusion around the methods. I can certainly relate to that, and you'll see with the LOOC-C carbon tool that we've tried to address some of the inherent complexity in the methods, just in a way of how we represent some of the information and describe those methods at a very high level. So I'll start with the LOOC-C carbon tool. The intent of this digital tool is to reduce complexity of what's on offer within the ERF. So it's very much tied to that scheme and the methods that are part of that legislation. We're also looking to reduce some of the uncertainty about what happens if you run a carbon farming project on a particular property. And that's where some of the deep science comes into play. The conversation that we're trying to help start with the LOOC-C tool is a carbon farming project right for me? Just really trying to take out some of the methods that aren't relevant to a particular enterprise and direct attention to things like the amount of sequestration that might be possible. And we do that by basis of some of the carbon sequestration models that have been developed within the organization over the last 10 to 15 years. What you see at the bottom of the screen are two screenshots from the web-based tool. On the left-hand side, this is a page where you identify that area that you want to explore, and you answer a couple of questions about the land history, and a little bit about the land future. The questions that we're asking here are directly in line with the eligibility criteria within the ERF. On the right-hand side just shows a couple of different methods that might be discovered when you use the tool. We present each possible method as an interactive card, so you can flip between the front and the back of the card. Here we're showing the front side of the card that gives you an indication of the sequestration potential, which then can be multiplied by the going price of carbon to get an estimate of financial viability. On the front of the card, you also see which kind of method it belongs to, which class, whether it be agricultural or vegetation. You can see in this vegetation card that it's got a different color and it's got a little bit of a warning on the bottom. So we do provide a couple of warnings or notices when something about our model calculation might be something you want to be aware of, like the viability within that area might not be a good candidate for this type of method. Another difference I'll point out is the difference between the purple card and the blue card. These purple cards have been specially customized for the Queensland Land Restoration Fund, whereas the blue ones is just straight out from the ERF methodology. This is an indication of how the tool's been customized since it's been released in 2019. We've done specific work based on a poll from states so far of Queensland and Victoria. Happy to speak a little bit more about that in a few minutes. This slide is really just an information slide for you going forward of how you can access the tool on the web via this address, and just specify some of the updates that we've made since launching that in December 2019, which was an event that we were really lucky to have Kate come and say a few kind words about. Since we've launched the tool, we've added more methods, those methods around measurement, as they've gotten a lot more attention since 2019. I've already mentioned we've specified some of the method discovery to the Queensland program, the Land Restoration Fund, and we do have another release coming quite soon that will have additional functionality providing information of different soil carbon data layers. We've also added some forestry methods that can be discovered, those tailored to Victoria. The product email address is just at the bottom. That does come into my inbox as well, so feel free to get in touch with questions, comments, or if you want to just talk about the tool with a deeper lens, that would be the best way to get in touch with us. We learned a lot from the LOOC-C process. We learned that some of the challenges within the scheme were and continue to be the source of low landholder appeal. I learned from the landholders and extension officers that I worked with in the user research that there's aspects about the carbon farming scheme that don't capture that holistic, productive nature of the farming system, and that can be a bit of a deal breaker. And that the ACUs were simply not enough to consider making such a substantial change to the business. Co-benefits really matter. And with the co-benefits research we did as a result of that initial finding, we found that biodiversity was the number one co-benefit that landholders were interested in, and that forms part of the intent of then the LOOC-B design process, which I'll talk about next. We've learned after the tool's been out there for a while that it's pretty intuitive and is handy for a number of different actors in the carbon farming space. And we learned that this data engine, this API, is highly desirable for kind of using the tool in anger, running a lot of different properties very close together in time, and that can be useful for those who are looking to prospect or compare different types of properties for the opportunity of carbon farming. So I'm going to pause there just for a moment. That was the LOOC-C spiel. Okay, carrying on. The LOOC-B biodiversity tool. This is another type of calculator that brings together human-centered design and aspects of our deep science. This is the science that Karel's team is responsible for and continues to lead. Our aim here is to recognize the co-benefit of biodiversity and quantify that in some meaningful and usable way so that the carbon farming actions that are taking place across Australia at different scales can be recognized and then potentially rewarded. So the conversation we're trying to start with this tool is, where am I at with biodiversity within my community, my farm, my catchment? How has it changed and how might it be improved? So what we'll get into in a bit more detail is that the LOOC-B tool has two different modes of analysis, that of planning and that of monitoring, and it's by supporting those two types of questions that we allow for the information to be available to both look backwards into what's happened and what the impact's been of past actions, also allowing us to look forward on what might be possible if we start changing management practices or leave them as they are today. The diagram or the picture at the bottom of the slide is just a graphic of what the tool is going to look like when you go to the website. Biodiversity can be measured in a couple of different ways, and those different ways give us different types of information, and so there are 5 different indicators that are available through the tool. That can be a lot, it can be a bit overwhelming, but it's really important for us to include all of these indicators so that we're able to apply the right sort of analytic lens when we're making these decisions about biodiversity for different reasons. All of these indicators are going to be based in this habitat condition indicator. So if you had to pick one, sort of the backbone of everything that the tool is producing, it would be this habitat condition, which is the capacity of that area to support native and existing species. This slide just provides you then the information to access the tool. You can go straight to the website here. It does require email registration, which is a little bit different to the LOOC-C tool. It's also available as both that UI and the API. Where we're at with the tool is that we had our first public release in May of 2022. That's where I met Rachel at the Carbon Farming Expo in Albury. And we're looking to refine the tool as we're getting more feedback. It's coming in a bit incrementally. We're also keeping an eye on kind of the decisions at the federal level being made around biodiversity. And so our next steps are really to listen to what's coming back to us in terms of signals to see how we might refine that tool. We know that biodiversity is being used by different actors for different reasons. So for the moment, we don't have intentions of aligning it to a specific scheme or program. We want to try and make it as accessible and usable to as many actors as possible. We have a very similar looking product email that you can use to get in touch, and the link to our research homepage is at the bottom of the slide here. I've included a slide of the team just to show that we're running pretty lean. We've got a diverse team, but there aren't very many of us. And we have had a number of conversations with Don Butler, who's an integral part alongside Andrew McIntosh with the stewardship scheme, and he's been able to provide some great advice across or over the past couple of months as we've been in this development process. And I think that might be it for me. So I'm going to stop sharing so I can see more of you on the call. I'm also happy to jump into a web browser to give a demo of the tool, but perhaps taking some questions if you have any first on the nature of the tool's intent.
Thanks so much for that, Cara. That was fantastic. And I mean, I'd love to jump into the tool in a second, but I can see people are actively unmuting and have hands up, so we'll go to them first. I think, Steve Ewings, you were first.
Look, just a question about functionality. One of the things, I mean, it's a great tool, the LOOC-C. I've used it many times. But one of the annoying things is not being able to import a shapefile. And so where you have a large property, you know, here in Western Australia, for instance, it's very difficult to draw freehand the boundaries. And I've had to resort to, you know, tracing a shapefile on a screen and overlaying it on the LOOC-C tool, and then using the, you know, the cursor to try and retrace that. I'm just wondering how difficult it would be to include that, because it you know, would add greatly to the.
Steve, thank you for sharing that. It's not the first time I've heard of that painful experience. It is completely doable to have a load file option within the tool, and it is something that we had as part of our minimal viable product for LOOC-B. So with the LOOC-B tool, you are able to import a GeoJSON file, and that's an alternate to drawing the shape in the map. However, we don't have that feature in the LOOC-C tool currently. One alternative would be to use the API. That's a different sort of interaction model where you type in the code of that file. And so I will take your recommendation on board and send it to Peter Fitch, who's managing the LOOC-C tool. It's something that we've heard again and again. Karel, are you able to comment too on how we might be able to work around that?
Sorry. No. No, it's hard to see. I think your approach is clandestine, but probably the best short-term solution. Yep. But as Cara said, we've got lots of solutions to that with LOOC-B.
Thanks a lot for that, you guys. Sorry, no immediate solution for you there, Steve, but hopefully in the future. But well, with LOOC-B, it sounds like there's a...
Yes, but as I think about it just for another moment or two, it does raise the issue of just how precise the map area needs to be for your inquiry. It could be that you can get away with doing a rough as guts sort of shape selection based on what you know of the property. It's just not going to be the exact same shape as that carbon estimation area that would go into your ERF registration process. Maybe perhaps that helps.
Thanks, Cara. I think Chris Norman had a question next. Did you, Chris?
Thanks, Rachel. Thanks, Cara, for your presentation. I guess I know the tool is only a conversation starter, but I'm interested in the source of some of your data that sits below it. So particularly the biodiversity persistence data, where does that come from as a base layer?
I will hand to Karel.
Yeah, great question. So the biodiversity persistence indicator is actually a calculation. It's analysis we do every time somebody interrogates a particular area. So it takes the habitat condition information that Cara said is kind of the backbone, and then combines that with information, basically maps of what we expect biodiversity patterns to look like. And it does an analysis specific to your area. So it's not a static layer as such, as an analysis that we provide. Yeah.
There's an enormous amount of data that underpins the LOOC-B tool. Quite a number of data sets that have been curated and cleaned. Some of those are based on-ground observations, but quite a bit of it is sourced from remote sense data sets. And in this way, we're really trying to overcome some of the challenges with those on-ground audits and provide a consistent, standardized way of looking at biodiversity across the country. Now, that doesn't go unchallenged, but as we need to really start getting these metrics at a level that we can deal with them in certain schemes, we need to learn how to leverage some of this big data.
Yeah, and I guess the challenge is, well, not challenge, the opportunity down the track is that we're all delivering biodiversity projects across the country, regional bodies that have got recent up-to-date information around a lot of the stuff that you're dealing with, but at a different scale. And if you could somehow get the interchange between them would be great, because it'd be continually feeding into your process and updating things. I'm not sure if that's fantasy world probably, and we've talked about it for years, but yeah, there's a lot of continual updating of information in the system somewhere, wherever that system is.
I guess in some of the conversations we've had with the states who have their own approaches and these really fantastic data sets, they're interested in using LOOC-B to kind of do a sense check to see how our tool lines up with their own approaches. And that work is, it's undergoing, and we don't have a clear picture yet. But what you've suggested about bringing the data together, having an alignment across the country, it's very powerful, and I do hope that we keep making our way to that utopian state.
Thanks very much, Chris and Cara. Alison Skinner from SA Arid Lands, I think you had a question. You unmuted, but then it was a bit windy, so I muted you. But I'm not sure if you unmuted because you had a question. You wanted to unmute. Or if we don't have Alison, we'll go. Chelsea, you've got your hand up. Would you like to ask your question?
Yeah, thank you. And thanks, Cara. Hang on a second. There we go.
Yeah,
just leading on from Chris's question, he asked about biodiversity persistence. And you mentioned there was a few different data, or lots of different data sets used to determine the habitat condition. I was wondering whether you could elaborate or just provide a little bit more information on what is used for the habitat condition.
Yeah, I can talk to that. So I guess the habitat condition, as we said, it's kind of fundamental and sits under our other indicators. It's an area that we're constantly working on and improving. At the moment in LOOC-B, that's based on, at the core, it's Landsat data, and it's actually using a product of woody cover. And so what it really reflects is how much woody cover the satellite sees, as opposed to how much woody cover we expect to occur in any particular place, given the environmental conditions and the potential woody cover in those conditions. So does that help give you an idea of what?
Would woody cover tell you how old the forest is? Is it a proxy for age?
Yeah, that's right. So that's right. So woody cover would increase and then plateau with vegetation age. Absolutely. Yep. So it's quite closely related to that, and we see that in some of the examples that we've explored with LOOC-B, where we can actually track for known kind of restoration sites, we can track increases in woody cover and similarly habitat condition through that. Yep.
Great, thanks.
Thanks for that, Karel. I just had a question based on that. sorry if this is sort of like obvious to others, but if you're looking at sort of woody cover, obviously that varies a lot for the, you know, vegetation community that you're working in, or the, you know, the maximum woody cover that you'd be aiming for and expect. So how's that sort of calibrated for areas like grassland for habitat condition?
Yeah, that's a really really good question, because it's not really suited at all to non-woody vegetation. And so I guess that's where LOOC-B is really focused on a use around landscapes that are naturally woody and either have been cleared and are being revegetated or considered for revegetation. So it's not completely inaccurate for the, I guess, kind of rangeland systems, although it starts to become less useful there. And certainly for those small number of areas that are naturally grasslands in Australia, not really suited well at all to those.
Okay, that's really useful, because in preparation for our talk today, I was running it over the Monero grasslands where I'm from, just to see what kind of condition you're expecting. And look, that was in pretty bad condition, which is pretty disappointing, given I thought some areas were pretty high condition. So that's really, yeah, really important to have that that noted. Anna, did you have a question, or are you just unmuted by accident? If no one else does have a question right now, it would be great. We might
Rachel,
go.
I do. Sorry. Yeah, sorry.
You go,
And
Kate.
we could probably all get a bit pedantic about this, because I think we're all, given the work we all do, we're probably all quite fixated on habitat, landscape functionality, condition, and of course data. But it is a really interesting one with regards using woody cover in that way. So thank you for the original question, Chelsea, I think it was, because then one starts questioning, of course, weeds, particularly substantive weeds, and then also fire history, and native fire history, and thinking about, for example, the, you know, woodland savannas across northern Australia, which can still sort of be structurally present and contiguous, but condition-wise be pretty sad. That makes sense, with very high loss of biodiversity, bad fire histories and damage, etc., as well as significant weeds. So I'm just curious as to how we're going as far as the reality checking around those sorts of problems as well.
Yep. Yeah. Obviously, really good points as well. And yeah, it's trying to measure these important attributes from thousands of kilometres in space is obviously going to always be limited. So often, yeah, some of those factors won't be brought in well. I just point out that some of our work that's going on right now is actually bringing some of those factors in. So particularly natural fire dynamics and potentially altered fire dynamics, and things like pine plantations and obvious things like that to improve that habitat condition. So yeah, really important points, and it's an area of key research for our team.
And other parts of CSIRO, I think, have been working on this sort of thing for a very long time as well. So presumably
various aspects of vegetation condition.
Yeah.
Thank you. Cara, did you want to open up your browser and just give us a quick run in LOOC-B?
Yeah, I'll be happy to do that. And I've been taking all the feedback that's been provided in the meeting so far. The opportunity to speak in venues like this is so valuable to us as we're early in our journey. It's been great that we've been able to put something out there, but to understand what the pull for this tool is and the criticality with which you're looking at it, it's just fantastic. I'm pretty stoked. Where am I? No, I'm just not getting the right option. Bear with me. Then I bring you on top. Here we go. Okay. So what you're looking at now is the landing page for the LOOC-B URL. It's a typical landing page giving you a little bit of information about the intent of the tool, how you're going to be able to get started, and there is a pretty nice 3-minute instructional video that also can take you through the steps of using this tool. But let's go ahead and just get started. I've already got an email registered to use the tool, so I just have to agree to the terms and conditions, which really just at this point mean that I'm not going to use the tool for commercial use, as we're still getting feedback about it. Okay, so now we're looking at the estimate screen. This is the screen through which you're going to submit your query. And my Zoom window is just in the way a little bit. So I've got my two different modes, that of planning and monitoring a change. I'm going to monitor a change that's already occurred. I'm going to select that backbone biodiversity condition of habitat condition. I'm going to say 2020-12. In this interface, I'm going to use the search bar to go to a particular region and WA. And this is working just like it does in the LOOC-C tool with the map box interface. I can move the map around by, just clicking and dragging. I hit the area tool, and that gives me the functionality to draw a polygon. And I'm just going to draw a polygon that's kind of in this area that I can tell has been used, and I'm going to suggest that something's been done. Okay, and then I hit the estimate button, and you can see that on the single page interface, then the results come through. And on the right-hand side, which I'm going to speak to first, it's you're getting the habitat condition indicator information in a couple of different ways. First, you're getting it listed as a percentage change across 3 different time periods. You're going to have an estimated hectare change. So this is saying that about 45 hectares of the complete shape size has the potential to change in habitat condition. And then we've also got that same information presented over a time series graph. There's another feature that's happening here, and that's within the map interface itself. You can see that there are some different pixeled colors, with red signifying a degraded landscape and green looking at more pristine environment. And this is showing habitat condition for 2012 because that's what's selected in this time series bar. If I move forward and select 2020, you can see that there's a difference in how habitat condition is changing within that shape. I'll do that again. So here we're at 2020-12 and there to 2020. So you can see that there's been some benefit to habitat condition happening in this corridor. And I believe that's aligning with a registered ERF project. Another part about the tool is the About page, which is going to give you more information about how the indicators are derived. It's also going to take you to our API documentation. That's the data engine. And so this is just one of those other pages which give you all sorts of information on the different types of layers that the tool is running on, and quite a bit of the science behind those different indicators. If you do have the data science background to use the API, there's all sorts of examples in a couple of different programming languages, and that's to make that sort of delivery mechanism quite accessible to you. We've had a lot of desirability for that, so it's quite accessible to some, and for others, including myself, it's just a little bit too complex. Okay, now back into our main interface. Let's say that I wanted to do another analysis. I can do that by just interacting with these inputs radial buttons on the left. Let me just take a different area. Again, I'm just clicking and moving the mouse around. And then once I have my input selected on the left and my area selected, I'll hit the estimate button and I'll get those inputs rather quickly than on the right-hand side. I do want to just point out that the LOOC-C carbon tool runs pretty well on a tablet or on it does okay on the phone. With the LOOC-B tool, really recommend using a laptop machine just because of the way things are going to render on the screen. It's not been optimized for a mobile phone, but it has been optimized to give you those insights very quickly. So again, just running through how the results are delivered, we deliver those as a percentage change, as a hectare change, and then along a time series graph. This showing habitat condition if you were planning this type of change in this region.
So when you say, sorry, Cara, I just wanted to interrupt you because I think you said it was about sort of looking at possible changes like a carbon farming project. So is this set to like the environmental plantings method? Like is it sort of based on, you know, the density of plantings and stuff that's under the ERF method or just generic?
We've got these. Let me make sure. I'm going to try and answer your question. If I do poorly, I'm going to see if Karel can help me out. We do want to have this tool aligned to carbon farming as described in the ERF methods. So we have these particular types of management actions listed, which is not the comprehensive set. And so they are aligned to these management activities, although they're not going to be aligned to the specific components of the method in the same way the LOOC-C tool is.
Thank you. And with the habitat condition, so is there a way to ask the tool like what habitat you're in, or is it just, because I think you sort of answered that question before in terms of it's sort of built on woody vegetation density, but yeah, I suppose, yeah, what other information does it have in it that you can sort of access about what's going on in the landscape?
Yeah, Karel, would you like to speak to that?
Yeah, it's good. It's a good thing we might add in future. We don't have, so I guess we're viewing the world as a continuum and not providing any, I guess, vegetation type information, but it's certainly something we could bring in. There's obviously important limits that we need to draw on how complex we make the information, but that's a really potentially useful one, I think.
Yeah, I was just thinking when I was running it the other day, and I ran it over some areas that were sort of grassy woodland and stuff as well, and you were looking at it, and I suppose with the threatened species mode, and you could see, you know, well, this area has high potential for threatened species, but I couldn't figure out how to figure out what threatened species I should be protecting there or sort of promoting. So
yeah, and that's mostly because there's so many of them.
Yeah, right.
That people would very rapidly be swamped in information. So yeah, I guess we've made these early decisions to try and keep it simple, but yeah, as Cara said, we're at the beginning of the journey. So these sorts of comments really help us with how we're planning the next stages.
Yeah, I suppose I'm just thinking about the wide usefulness of the tool if you kind of have some more of that information, I suppose local information that might underpin it. Chelsea, you've got your hand up. Would you like to ask your question?
Yes, thanks. Yeah, I was going to follow on from what you asked about the different sort of vegetation communities. So when you say that the woody vegetation cover as it increases, the biodiversity or the condition would increase as well. Is that based on a benchmark or how woody that vegetation community should be? And I guess that way you could pick up that in over, you know, those savanna communities that are more woody than what sort of a benchmark condition would be or best on offer. And then I had another question, which was, it sort of came to mind that woody cover was what I thought was used to measure carbon. So what's the difference between if you're using woody cover to measure carbon and you're using that same attribute to measure vegetation condition? Is there any key differences between those two data sets?
Yeah, both very good questions. So the first one about, I guess, references, that's very much how we train that habitat condition data. So within each within each kind of region, and we basically look at the common environments and look for the for those places where you have vegetation in good condition, and they're essentially the benchmarks for how we expect. So if you go to like a wet tropical rainforest, we need to get a lot more vegetation cover before we're in good condition than if you go into kind of Western New South Wales, for example. So we very much use those, and they're just from within the data, those reference sites. In terms of the alignment with the carbon data, that's very much what's being used in the I guess the revised version of habitat condition that we're working on right now. So it's going to align directly with the NCAS information on distribution of forest and scattered woody vegetation. So that's something we're intentionally aligning with in the coming I guess iteration of those data. So we very much see the use in that alignment, and they are good data as well. So.
Yeah, I think that's a really great question, and I appreciate you taking that, Karel. But it shows how these tools are not an end in of themselves. It's a means to an end, and we're learning that if we build the tools in a flexible way, we're able to better integrate as more information comes to light, and as we see these new ways of applying the data and the information. So while a number of really great suggestions have come out of this conversation of how to improve our tool, there are other suggestions of how this tool might be integrated with other types of spatial layers and data services. And that's where this API is so important, because it provides that sort of common denominator, or almost like if you can think of you're building your perfect poker hand with your different digital services. LOOC-B is one, but you can put that right up against some of the other better data layers that you have on hand and some of the questions that you want to ask of the indicators. Hope that helps.
Thanks heaps for that response, Cara. Kate Andrews, you have your hand up.
Yeah, I'm going to move on from the data discussion, even though I think we could probably all get suckered into that for quite some time, because it sounded really interesting when Karel started talking about training the data. And I started thinking there's obviously some great thinking behind there about the learning process that your system is going through to improve. So that would be interesting at some stage to talk about or hear more about, particularly because I think it captures that idea that data itself is no longer static, in the sense that we're always able to feed more in. But the question I wanted to ask was with regards to industry sustainability frameworks, Cara, and we can always have this conversation offline as well, but it just seems that, as you say, if you build a really flexible tool that can be used for multiple purposes, because of the fact that it's tapping into those data but providing you with certain levels of, a modelling of reality, then it just could be a really interesting one for agricultural industry sustainability frameworks, where people are trying to find ways to be able to not just present where things are at with biodiversity, but model how things could be improved. So if you are, for example, in the cotton industry, needing to show that in fact you can be nature positive, and you are needing to account for biodiversity and show where you can improve over biodiversity over time, etc., etc., it would seem that something like LOOC-B could be really, really useful. But that's probably another conversation, but an example perhaps of how something like this could be applied elsewhere.
Yes, it's an excellent example. And it's a testament to what we've learned just in the 2 years that the project ran. We started with that clear intent of quantifying the co-benefit to help the carbon farming effort, and quickly we're flooded with all other areas that this could be useful within the agri-food industry.
Thanks very much, Cara. Did anyone have a final question or comment that they'd like to make to Cara and Karel before we let them go? No? Great. Thanks so much for joining us today. That was really great to get that run through and have the opportunity to ask you guys the tough questions and put in a few suggestions for some future flexibility in the tools. So we'll really keep our eye on how it's going in the next iterations of both LOOC-C and LOOC-B as they come out. But thanks so much for joining us and really appreciate your time.
Great. Thanks for the opportunity, Rachel. Good seeing you all.
Thank you. Bye.
Thanks, everyone.
Thank you.